This question is a motion problem. A group of students drive both a car and an SUV on a ski trip. The car left first and traveled at 55 miles per hour. The SUV left 2 hours later and traveled at 65 miles per hour. How long will it take the SUV to catch up to the car? A couple of things to notice as we begin our familiarize step is that we're given the speed, 55 miles per hour for the car and 65 miles per hour for the SUV. Since this is a distance problem, we'll be looking at distance, speed, and time, and we know that distance equals the speed or the rate times the time. So we're given the speeds. The distances will be the same because at a certain amount of time the SUV is going to catch up to the car, which means they will have traveled the same distance. The times we don't know, and that's what we're asked to find, how long it will take the SUV to catch up to the car. So let's let t equal the SUV's time of travel. Now, if the SUV travels t hours, then t plus 2 is the car's time of travel. And that's our first step, familiarizing ourselves with the situation. Now we want to organize this information in a table. And we can organize that for any motion problem, letting the columns be distance, speed or rate, and time. Then the rows stand for each of the motion situations. In this case, we have the car and the SUV. Now we can fill in everything that we know in the columns. We're given the speed of both cars, both vehicles. The car travels 55 miles per hour and the SUV 65 miles per hour. We know that the time of the SUV, we said we were going to let that be t, and the car's time we were going to let be t plus 2. The distances are the same. We'll call them both d. Now from this first row of the table we can get an equation since distance equals the speed times the time. And we can get a second equation from the second row of the table since distance equals speed times time. So in step 2, translate, I can get two equations. D equals 55 times t plus 2. And I can get a second equation, D equals 65 t. Now I'm ready to solve. To solve this system of equations, I can use substitution. Since D equals 65t, I will substitute 65t for D in the first equation. That gives me 65t equals 55 times t plus 2. This is another way of saying the distances are the same. I can solve for t now. I have 65t equals 55t plus 110. Subtracting 55t from both sides, I have 10t equals 110. Dividing both sides by 10, I have t equals 11. Now I haven't solved for d, but do I need to? Well, let's go back and look at our original problem. And that said that we were asked to find how long it will take the SUV to catch up to the car. In other words, we're looking for t, which was the SUV's time. So we don't need to go on and solve for d or anything else. We found what we believe will be the solution. So we move to the next step, and that is to check our answer. We have that the SUV's time was 11 hours. That means the car would travel 13 hours. Well, let's check the distances. The car's distance would be 55 times 13, or 715 miles. The SUV's distance would be 65 times 11, or 715 miles. The distances are the same, so the answer is check. So it would take quite a while for that SUV to catch up to the car. In fact, we can state our answer. It will take the SUV 11 hours to catch up to the car.